Good afternoon, everybody. It's great to be here. Thank you, Amanda, for inviting me to speak. I'm very excited to be able to share with you the results from this study. So maybe before we get started, some background and maybe some credits to others who participated. This was a pretty big study. Like Amanda said, the Texas A&M Transportation Institute, whom I work for, we were the lead agency who performed the project. We worked with the University of Denver, specifically Dr. Donald Stedman, who is considered to be an international expert in remote sensing and emissions measurement in that way, and I'll talk a bit more about that. This study was funded by the Council of Governments along with the Texas Department of Transportation. And the basic question that we were trying to answer was that, does it make sense to implement a heavy-duty diesel inspection maintenance program in the DFW region? And, if we were to design such a program, what would it look like? What could the potential benefits be from an air quality perspective? So that's kind of, the question that we set out to answer. Amanda covered these really well, so I'm not going to go into much detail. Basically, why are we even doing this? The region is in air quality non-attainment, so there is a need to, demonstrate conformity because otherwise it holds up funding for transportation projects. And specifically, inspection maintenance programs are generally used to identify high emitters in the vehicle fleet. So there's kind of conventional wisdom that says that a disproportionately large amount of emissions generated by the vehicle fleet comes from a very small number of vehicles. Sometimes it's as small as the top, say, 25% of emissions comes from the top 5% of the dirtiest vehicles, for example. So the idea with an inspection maintenance program is to see if you can catch these vehicles that are high emitters. Sometimes they have like malfunctioning emissions control systems. So see if you can identify them and clean them up as a way to improve air quality. Texas currently, in its non-attainment areas, has inspection maintenance programs for light-duty or gasoline vehicles. So just like you go and get a sticker, the annual sticker for safety, you need to do the same thing for emissions as well. But currently, Texas does not have this for diesel vehicles. And the other thing I just wanted to distinguish, which I will be talking about in this presentation, is that you have inspection maintenance programs, which usually are where you take your vehicle in every year and get it tested. You also talk about screening that can be used as a supplement to inspection maintenance programs. Sometimes the screening is set up in, like, using remote sensing. So you set up a remote sensing device on the roadside, and using license plate capture and sending the remote sensing signal, you can see if the emissions coming out of the vehicle tailpipe is higher than what it should be. You can send these people a letter. So unlike an inspection maintenance program, this is not legally binding, but if you send them a note, perhaps like the smoking vehicle program, those kind of approaches to screening of high emitters. And then the EPA also talks about clean screening as a way to use remote sensing to find out if vehicles are clean. They don't need to go through the whole inspection maintenance program. You just screen them out and then focus on the vehicles that are not as clean. These are different approaches to inspection maintenance or screening programs. You have remote sensing that I talked about. You have onboard diagnostics, so the computers on board our vehicles. And in the light-duty side, most of our vehicles have these. I think starting from the 90s, OBD2 was required on these vehicles. So this is kind of just the context. So we don't currently have anything in Texas on heavy-duty or on diesel inspection maintenance. As Amanda talked about, heavy-duty diesel vehicles, these big trucks, are a significant contributor to NOx emissions, and so we kind of focused on that in our study. So the approach was to first look at, other states that might have had heavy-duty inspection maintenance programs or diesel inspection maintenance programs. What do they do? What are the different approaches? And then this was the fun part. We got to conduct an on-site pilot study that I'll talk to you about to characterize NOx emissions using this fairly new and kind of innovative technology called the shed. It stands for something, and it literally is a shed as well. And I'll show you some pictures. And basically look at the data, look at how valid that data is compared to maybe other methods, and see if we could, potentially use this information towards designing an inspection maintenance program for heavy-duty vehicles. So the SHED stands for Streamlined Heavy-Duty Emissions Determination. And basically, what it does is you have this shed, and as the vehicle goes through it, with these trucks, their smokestacks are usually up there, and so the emissions go up into a series of analyzers, and the concentrations are measured, and then we have computers hooked up to the system, and it can tell you what the emissions of that truck are. If it's higher than it should be, you might have a cutoff point, and then you can look at the truck license plates and kind of match it up to the model year, and it gives you a lot of good data that you can use. We also did some portable emissions measurement systems or monitoring system, PEMS, and this was kind of used to check whether the data that we got from the SHED measurements were consistent with kind of an established method of measuring tailpipe emissions. So the PEMS are basically kind of expensive, sophisticated equipment that you hook up to the tailpipe of a vehicle, and it tells you, what the emissions are. We also looked at conventional remote sensing, but we did not actually deploy it on site. The Professor Don Stedman, who worked with us on this, is considered the father of remote sensing, and the SHED was seen as a way to extend his work in remote sensing into kind of a different application. And we also did opacity measurements, which is the smoke meter, but I'm not going to talk too much about that because that is found to be not that beneficial for NOx emissions. So because it's looking at opacity, particulate measurements are what it's really useful for. But we did it, and while I'm talking about NOx most of the time, in our study we did look at other pollutants as well. But obviously NOx is the most important. So this is our test site. Basically, in order to set up this shed, we need a place where we could divert trucks and make them go through this shed measuring device. So it had to be a weigh station. We worked with the Texas DPS, and they actually allowed us to take over a weigh station and flag trucks off the highway and make them go through our testing site. So we looked at a few candidates around the region, and we finally settled on this one, New Waverly Weigh Station on northbound I-45. This site was further away from the DFW metro area than some of the other candidate sites, but most of the heavy-duty diesel vehicles passing through that region were headed for Dallas. So essentially, we felt it represents vehicles that either go through Dallas or operate in Dallas, or in your region, the NCTCOG region. We did the testing about a year ago. It was about 2 weeks. We got about 1,400 vehicles. We managed to interview about 1,300 drivers, and we validated our data based on driver interviews as well as looking at the highway network, and we got a good sample of vehicles that are headed for your region. So this is just some pictures of the site, and like I mentioned, the drivers would see a sign telling them to pull over into the weigh station, and then we could flag them over. We could control like the control booth of the weigh station, and then they would go through our test setup. So this is what it looks like. You have the equipment up there that sample the emissions coming out of the truck. So the truck is told to drive through it. We have somebody over here, who'd ask the driver questions. We'd tell them to go through it. And then we have a trailer with equipment in which we captured the license plate of the truck as well as the emissions measurements as well. So based on the data that we collected, we were able to get license plate data for all Texas-registered vehicles as well as those from 5 other states. And this is just to show you that if we look at the vehicles, if we look at the Texas model year distribution, so you have vehicles from 1983 all the way to 2013, and these are just their numbers. So you can see generally, the fleet that you see on average is a few years old, the vehicles that you see on the road. So the general Texas registration and the vehicles we saw on site were very similar in terms of their age profile. So it kind of showed us that the vehicles that we're seeing are pretty representative of what you might expect to see out on the road. One caveat over here, which I'll be talking about a little more, is that since we had a site on an interstate highway, these are long-haul trucks. if we were to extend this pilot study to look more at, local fleets housed in a certain area, generally older trucks are used for these short-haul, operations when compared to these long-haul ones. So it might be that the vehicles would skew a little older, and that kind of, and which would obviously mean that we might be seeing higher emissions from the high-emitting vehicles than on this one. But that's something we want to follow up with a future study. So the results that we saw from our data was that there is a really good correlation between the shed and the portable emissions measurement. There is a really good correlation as well between the conventional remote sensing, where you don't touch the vehicle, you have a remote sensing device set up by the roadside, you aim it at the vehicle's tailpipe, you take a measurement, and it tells you about whether it's a high emitter or not. And there was a good correlation as well. As I mentioned, opacity really doesn't tell you too much about NOx. So if we look at the high emitter impacts, and this is by using kind of an arbitrary cut point, if you take the top 7% of vehicles, the top 7 high-emitting, 7% of high-emitting vehicles, they are found to contribute nearly 20% of NOx. And like I said, if we had targeted local fleets by getting a test site maybe closer to the city, this might be even higher. But it shows that, and if we brought all of these vehicles down to emissions levels that the average fleet sees, we estimated that it's about 6 to 7 tons per day of savings in NOx that you could potentially get. So these high emitters are a problem, and I think targeting them definitely makes sense. This is just a couple of graphs to show the fact that overall, and this is understandably so, the high emitters are older vehicles. If you do that other analysis that I showed previously by taking that into account, you still see that they are contributing a lot of the emissions, and that's expected. But this is just something to consider. If the finding is just that older vehicles emit more, that is a concern from an inspection maintenance perspective, in the sense you could just start to look at vehicle replacement type programs instead. But at the same time, if you look over here, it's not necessarily a downward trend alone. So newer vehicles sometimes do emit higher. And there could be reasons including, the SCR systems or the catalytic reduction systems not working as well in the newer vehicles at the speeds we measured. But I just wanted to share that as well. So overall, we talked about how do we use this shed for inspection and maintenance. So the possible approaches are use it for a conventional inspection and maintenance. So any vehicle registered in this region would have to go every year to the shed and have its emissions checked out. Or you could use the remote sensing approach. So you set up a remote sensing device at major areas, where there's a lot of truck traffic. Check out a vehicle, match its license plate. If it's a locally registered vehicle, make it come into the shed for testing. If not, you could also do real-time remote sensing screening. So similar to what we did, we flagged trucks at random. You could flag them based on the remote sensing results as well. And there are many other approaches that we talked about in our project. And we just also compared different approaches to inspection maintenance programs with the shed. So we looked at the cost, we looked at how many vehicles can it process in a day. And the one thing over here is that if heavy-duty onboard diagnostics becomes common for most vehicles, it might end up being a cheaper replacement to other inspection maintenance program approaches. However, that's going to take a long time. So, the point we wanted to make is that the shed approach is relatively cheaper when compared to other inspection maintenance approaches, like using a dynamometer-based testing system. And if you think about the fact that at some point you're going to move to an OBD-based system, something like the shed or remote sensing makes sense. So in conclusion, this study gave us kind of a lot of interesting findings about heavy-duty diesel vehicle inspection maintenance programs, about how emissions characteristics and high emitters works. The main conclusion is that screening with shed is definitely a useful tool, or an I&M program, and it can definitely help identify these high emitters that contribute a lot to the regional emissions. However, we see this as a pilot. I mean, it was called a pilot program, and there's definitely more work to be done in terms of optimizing the shed to make it perform even better in terms of the dimensions, in terms of the type of frequency of the sensors, things like that. If it were to become an inspection maintenance program approach, there would need to be buy-in from EPA, from TCEQ, and many others who are involved. And targeting the short-haul or local fleets. So it might make sense. These findings show that even with the cleaner long-haul fleets, a big proportion of emissions comes from high emitters. We speculate that if you look at the local fleets, it's going to be even more. So this is definitely something that could be of interest and needs some study. And also think about the shed with respect to other approaches or methodologies. So that's all I have, and this is my contact information, or if you have any questions, I'd be glad to answer them.